So for part A, okay, for quadratic equations, you can always verify if you want to, but unlike square root equations where you have to verify, you have to check, these ones you don't have to check. So if it works, it's going to be fine. You won't have to check it. We only have to check with square root equations so far. There's other equations later on, logarithmic equations you have to check, things like that. But for right now, once you solve these, the answers will be right. You may want to check them just to make sure you haven't made another mistake. Now, right now, in part A, we have three things added together which equals 0. If we can change that from adding and subtracting to multiplying, then we can use the zero product property. So right now we say, can I factor that first one? There would still be an equals 0 here on the right. Well, if we think about FOIL here, the only way to get x squared would be x and x. How can I get 56? 8 and 7. Do those outside and insides make 1? With 8 and 7? Yeah. Okay. We'll want our 8 to be positive and our 7 negative so that our outside and our inside make a positive 1. And we've just changed our adding and subtracting to multiplying. Here are two things that are multiplied together. So often when we're doing our solution, we sort of split them up here and we say, the first one could be 0. That would work, right? If the first thing is 0, 0 times anything is 0, what would x have to be to make the first one 0? Negative 8. The second one could be 0. What would x have to be to make the second one 0? It would have to be 7. And there's our two answers. Of course, if I was getting you to guess and check, a number squared plus a number minus 56 is equal to 0. Might have been a long time to guess negative 8. But now that you can factor it, you can get your solutions right away. Notice the second one on the left-hand side is already factored, but it's not equal to 0. You can only solve two numbers equal to 0, knowing what one of the numbers is if it's equal to 0, right? Because I could pick, I got two numbers in my head that I multiply together to get 16. What are the two numbers? You might think 2 and 8. No, it's not 2 and 8. I'll probably be nasty as a math teacher and pick something like 3 times 16 thirds, right? And so you would guess forever before you would get that. Because you'd guess 2 and 8 and 1 and 16 and 4 and 4. And then maybe you'd try negative 2 and negative 8. But there's an infinite amount. Because it could be 16 fifths times 5. It could be 5 thirds times 48 over 5. It could be a bunch of different possibilities. So for B, currently, we can't solve this. The only way we can solve it is if it is equal to 0, because we're going to use that zero product property. So what we have to do is we have to expand everything out first. So I'm going to FOIL the side here and get 3x squared minus 18x plus x minus 6, still equal to 22. And then bring my 22 over to this side to get 3x squared minus 17x minus 28. And now that it's equal to 0, now we have to factor again. This is plus x here, yeah, minus 6, because I foiled this out up here. We're on part B. Okay. So now, for factoring this one, it's not too bad because it starts with a 3x squared. What is our only possibilities for the first ones? 3x and x. What multiplies to give you 28? 4 and 7. So if we try 4 and 7, what's my outside? No? What's my outside? 21, right? Can you see the outside would make 21? Inside is 4. Do 21 and 4 ever make 17? Yes. You would need your 21 to be negative and your 4 to be positive to make a negative 17. Now, either one of those could be 0. Which side looks easier to figure out x? X minus 7. Let's start there then. What could x be if the right one is 0? 7. Perfect. Let's go to the left one, because the left one could be 0 too. What could x be to make that 0? Negative 4/3. How do you do that? Well, off to the side, if you can't see it directly, you say to yourself, well, if I want 3x plus 4 to equal 0, how would I solve for x? I would subtract 4 on both sides. Then I would get negative 4. Then I'd have to divide both sides by 3. And I get negative 4/3. Eventually, you're going to go directly from here to the answer, because you're going to say, oh, I'd bring the 4 over and divide by 3 to get negative 4/3. But right now, you could do this off to the side as well. I mean, if you really wanted to, you could do this one as well. What could I do to both sides to get x by itself? Add 7 to both sides and solve. But most people can see something minus 7 equals 0. X has to be 7. The one with the fractions a little bit harder. Okay? So, if we can factor something and we make sure that it's equal to 0, then we can solve it. And especially in this last one, if someone had said 3 times a number plus 1, all times by a number minus 6 is equal to 22, and you were trying to guess and check that one, it would take a very long time. But if we can make it equal to 0 and factor and solve it, we can solve these complicated questions. Okay, you're going to give you some time to try some of these. Okay. Something to be careful of is you get so excited about factoring because you're so close to getting the answer, a lot of people forget to write equals 0 as they're working. And that's an automatic half-mark deduction all the way through. So it had an equals 0 here, it needs an equals 0 here, and then when you solve it, you can write your 2 answers. Okay, practice some of those.